Good morning, everyone. Thank you very much for joining us today. My name is Rosemary Keene. I'm a communications specialist with the Soybean Innovation Lab. And today, Dr. Carrie Clark with the University of Missouri and SIL researcher will be speaking to us about the Soybean Innovation Lab's multi-crop thresher. Just a bit of background for those of us who are new to our webinars. The Feed the Future Innovation Lab for Soybean Value Chain Research is the USAID's only comprehensive program dedicated to soybean research for development. SIL is building a foundation for soybean production in Africa by developing the knowledge, innovation, and technologies to enable successful soybean production. Today, we'll be hearing from Dr. Carrie Clark, who is a senior research specialist with the University of Missouri. She leads SIL's efforts in our improving and developing mechanization research portfolio. And today she'll be speaking to us about SIL's multi-crop thresher.
Thank you, Rose. Are you going to do the first polls first?
That's correct. I just wanted to see if you had anything to add. So before we begin, we're going to do a couple of polls about our audience's experience with threshers. So I'm going to launch the first one now. And you will have 15 seconds around about to complete this. Closing it down shortly. Great. And here are our results. Do you currently use thresher technology, and is it locally made or imported? And a good portion of you said no. Our second poll this morning, you'll have about 20 seconds to answer this one. Great, and closing it down shortly. And here, what potential challenges do you face with thresher technology, either currently or in looking to adopt thresher technology? Availability, affordability, servicing, quality and capacity, or safety? And it seems like our front runners here were availability and quality and capacity, as well as affordability. Just a few extra housekeeping items before we go ahead and get started with the rest of the webinar. At the bottom of your GoToWebinar panel, you'll see something called handouts. Within that section is the thresher packet. This is a document that gives you a lot of the information about the thresher that Dr. Clark will be speaking on today. Additionally, if you have any questions, please feel free to use the chat box, which is at the bottom right-hand corner of your GoToWebinar control panel. Feel free to ask those at any time throughout the webinar, and we'll be sure to get those answered for you. Without further ado, Dr. Clark, take it away.
All right, thanks, Rose, and thank you guys all for joining the webinar today. So I want to tell you guys just real quickly about how we got to where we're at now. So as Rose said, you know, we're a soybean innovation lab. So what are we doing in threshers? Well, we saw pretty quickly when we started working in soybeans in sub-Saharan Africa that the ability to thresh was a major limiting factor for most smallholder farmers. So originally we wanted to provide designs for threshers that were small enough to be affordable for smallholder farmers. So you can see this was the picture there on the right.
I'm sorry, Dr. Clark. The poll is still showing.
Oh.
I apologize. I'm not entirely sure why that's happening. I apologize. Just
Is it off now or still on?
I'm sorry, it's still showing as the poll. Please excuse me, I'll try one more thing. Many apologies for our attendees this morning. Carrie, I know that it still says showing the poll on your screen. Is that still visible on your screen?
I still see the poll, yeah.
Okay, it's supposed to have been closed down. Is there any way we can switch over to sharing your presentation?
There, can
Perfect.
you,
That is
okay,
it.
you guys can see it now.
Many,
Okay,
many apologies. Thank you everyone for bearing with us. Sorry, Dr. Clark.
no problem. Okay, so so you guys can see the thresher there on the right was the first one we did. So we were also asked by an NGO in Ghana to make a bike-powered version, which we did also. So what did we find? Well, we field tested those threshers. We tested them in 3 rural communities in Ghana. And what we found was that pretty much all end users tried to thresh more than the capacity of the small threshers. So they tried to, expand it to more than just one farm, or they tried to shove things into the opening, which jammed up the thresher. So we also found that the price of the small threshers was still too high for most smallholder farmers. During our field testing, we also realized that maintenance and repair were potential problems for people who are unused to any mechanization. And then during village or community surveys and focus groups, we were pretty much told that nobody's going to pay for a thresher that did not also shell maize. So our solution was to completely change the focus of our program. So now we focus on threshers that have a high enough capacity to anchor a service provider business. So the service provider being somebody that would service maybe 30 or 40 farmers and would make a living out of being a thresher provider. And we also wanted to make sure that thresher is safe for the users. So we designed a thresher that could be used for multiple crops, including maize, rice, and soy. We've been field testing that with farmers. We also train fabricators to manufacture threshers locally, which is a major aspect of our thresher program, that we do believe in local fabrication. And then we have also built a training program for end users for maintenance and repair. So to go over those objectives first, so we focus on threshers with high enough capacity to anchor a service provider business. We used 2 Ghanaian fabricators who had extensive experience. They provided designs and working models. We then field tested those. They have variable size motor capacity. The one in the photo has an 8 horsepower motor. You could also have a PTO drive instead of a diesel motor. The capacity or the speed that the thresher can go is only constrained by the speed of loading. So the thresher itself can put as much as you can put in it, or can thresh as much as you can put in it very quickly. But what's slow is putting things in it. Of course, maize loads a lot faster than soybean. And then we wanted something that could be easily pulled by various, like a motorcycle or a tractor or even a donkey. So one aspect of this thresher is that the chaff cleanout is through suction directly from the threshing chamber, and it's not by wind blowing out over the seed. And I'll show you some pictures of what I mean about this in just a second. So this kind of a chaff cleanout we found led to 0 grain loss from the threshing chamber. When we field tested this against machines that used wind cleanout, where it blows across the seed, we found that this thresher was much more efficient with much lower grain loss. So here's a photo of a typical thresher design that we've seen throughout Africa. And so you can see that there's a blower fan on the left side. The seed is fed into the threshing chamber at the top, the seed drops down, and then that blower fan blows across the seed to blow the chaff out. And that design we found has very high grain loss because of that fan blowing against the exiting grain. This thresher can also be extremely dusty for the operator. Here you have a guy that actually has to use a stick to try to get the chaff to not clog up. But the biggest thing I found on this was that the operator's hands get really close to the threshing drum. As I was watching this machine being used, I was sure I was going to see somebody lose a hand. Also, I watched many operators try to stuff plants in with a stick, and at one point we did see a stick get sucked into the threshing drum and fly out the other side, which was extremely dangerous. So both sticks and hands can get sucked into that threshing drum. So this is from not this light blue colored thresher, but a different one. But it was also one that has the fan blowing over the beans to remove the chaff. And the pan on the top is how much loss. We caught the loss in a tarp, and that's the loss compared to what actually was threshed in the larger white pan there. So it was, by weight, it was a 10% loss. So that can be very significant because you can see that's not a whole lot of soybeans there. So, you know, that we've threshed. So that's a large loss for the amount of soybean plants threshed. And in fact, there's been calculations that if you lose 44 seeds in a meter square of harvested area, that's a loss of 67 kilograms per hectare of yield. So that can really add up. So it's important that we not have threshing machines that lead to larger loss. So this is the sill thresher. You can see I've marked the threshing chamber there, and then the exhaust fan is actually off to the right of the threshing chamber here. So it pulls the chaff out of the threshing chamber and then exits out the chute. I don't know if you guys can see my arrow, but it exits out the chute there in the middle of the photo. So that keeps the wind from interfering with the seed and makes it go to zero loss. So the seed actually comes out clean enough then to be directly bagged. I will mention that we started out with this model with 2 wheels, but we ended up making it into a 4-wheel model during field testing because people were having trouble picking it up like a wheelbarrow and moving it around. So when we added the second axle and the other 2 wheels, it did add $150 to the cost, but it made it significantly easier to transport. So where they put the grain in is at the very top at the end of a long chute. So now you're not going to be able to get the operator's hand into the threshing drum, so it's much safer. One issue here, though, is the operator does have to be elevated to get enough distance for the grain to fall. So the machine does have to be somewhat tall for all the functions that it needs to occur to happen. So in this case, in this community, they chose to stand on a log, but we will be encouraging people in the future to come up with a better way for the operator to stand. So then you can see here at the bottom left, the chaff, you can see corn chaff coming out here, so that exits away from the operator. And when you do maize, the husk does not have to be removed before shelling. And again, you can see the chaff coming out the exit chute. Here it's to the right. So when you thresh soybeans, this machine threshes soybeans about 40 times faster than stick beating, and it creates very little dust. So our second goal was to design a thresher that can be used for multiple crops, including maize, rice, and soy. We did field test with all those crops, and it worked well. So the way you turn this into a multi-crop thresher is that the threshing chamber top can be easily unbolted and accessed. Here you can see they've got, in the photo to the bottom right, they've got the top of the thresher off. So it's just a few bolts and it comes right off. This is the sieve concave to the left, and we have interchangeable concaves according to what crop you want to use it for. So those concaves, here, if you look along the edge of the concave, you can see a bolt. So they unbolt very easily, and then they're interchangeable. So one thing that is very important, though, is when these machines go out, because the users need wrenches, it's important that the fabricator make sure that the user has the correct wrenches that they're going to need to do these operations. So you open the top. You don't have to remove the threshing cylinder that you see there with the spikes on it. All you do is you unbolt the sieve concave and you just pull it out from one edge and then put the next one in and bolt it down. So field testing with farmers, we tested in 2017 in rural communities in Ghana, and testing will continue in 2018. The design's currently being used by farmers in the Upper West region of Ghana. We're also having a workshop August 6th to 11th for modifications and final plans. So then after that workshop, the designs will be publicly available. So a highlight of our program is that we train fabricators to manufacture threshers locally. And I feel like this is very important because local fabrication can lower costs and it creates jobs. Local fabricators are more in touch with their customers' needs and they can adapt to their customers' needs. And the best fabricators that I work with in Ghana are ones that actually go out to the field, see how it's running, and get constant feedback from their customers. Local fabricators are also going to be able to repair the machines and advise, which is going to extend the life of the machine. So they can help teach the end users how to use it. They're readily available for repairs and can help people locate parts. And when you look at the history of mechanization in the United States, U.S. mechanization actually started with small local shops doing fabrication in conjunction with farmer input. So why do we not just give the designs to fabricators and let them do as they wish? Why do we train them? Well, to begin with, not all fabricators can read CAD plans, which is computer-assisted design. So these are like 2-dimensional or 3-dimensional plans. And for some people, those are going to be hard to read, especially without experience and training. So that's one of the things we do during the training is teach them how to read the designs and how to actually put those into use. Without training, you'll see a lot of fabricators are going to reverse engineer, meaning they're going to find a equipment imported or locally made piece of equipment and look at it and figure out how it was made and then make it themselves. And the problem with that is that can lead to inferior products that may lack important design elements. There may be some crucial element that they missed when they were looking at that will make that go from what was a functioning thresher to one that doesn't work well. Training helps improve product quality and the chance that the user will be able to successfully maintain and operate the machine. So if the fabricator has a good understanding of consistency and quality from product to product, that will create a more consistent product for end users and be able to allow end users to exchange information and experience between each other, which helps ensure proper operation and maintenance. Then again, training creates a network of artisans that will support the industry and end users. So we have found that when these guys can talk to one another, new ideas come up, modifications that work get passed from fabricator to fabricator, and they just have somebody to talk to and figure out what's working and what's not working in their business. So this is what a CAD design would look like. So that's just a 3-dimensional drawing, and then so these are the designs that are given to the fabricators, and for something like this is kind of confusing. They don't really know what to do with that. So during our training, we go through how you utilize a design that looks like this. So we did our first training of 12 fabricators in Ghana in 2016. It was a training funded by Advance and ATT, which is ACDI, VOCA, and IFDC. During our training, we actually built machines. We broke into different teams, 3 or 4 at a team, and built different kinds of machines. It's a 6 to 8 day training. It includes teaching basic math skills such as the calculation of circumference and area. It includes design reading, business development, quality control, which we find is something that has been missing probably in local fabrication and production. We talk about part sourcing and production efficiency. So currently, most fabricators in Ghana fabricate, if they get an order for 10 threshers, they'll fabricate each thresher one by one. And so what we discuss is how using an assembly line method makes you more efficient and can lower your costs. And then we also work with the people that we train on customer support and how they will find and keep customers and learn how to work with the customer in field testing. So as I said, the training includes production of a thresher. So it's still, we either train local fabricators or we train the trainers.
And also,
We're also following up.
just a quick reminder for everyone who's attending. If you have a question about any of this great information that Carrie is presenting, please feel free to use the questions pane or the chat pane down below. And also to remind you that there is a thresher packet, which is in the handouts section of your control panel. And that contains a lot of this information as well for you to review after the webinar. Sorry, Carrie. Thank you.
No problem. So you can see here to the right, we also have followed up with our initial training crew of fabricators that we want to help make sure that their businesses are successful. So we've provided them with signage that says that they're a multi-crop thresher fabricator, that gives their information so that people know that when they go to that shop, that's a product they can find there. So we're following up. SIL and Catholic Relief Services are following up in Ghana with a 3-year research project. We're looking at the effect of thresher use on post-harvest loss reduction. What are the barriers to local thresher fabrication, and what policies and practices need to be initiated to overcome those barriers? We're looking at issues surrounding different ownership scenarios, such as like a nucleus farmer that leases to outlying farmers, or a service provider, or individual ownership, and what issues go with those, and also looking at financing issues. We want to look at the socioeconomic and human health costs and benefits of the different kinds of threshing, like stick threshing versus machine threshing, and provide, basically what we're looking to do is to provide backup information, so when your group goes to a funding agency, you have evidence to say that yes, threshing needs to be funded. Threshing programs need to be funded because it, improves post-harvest loss reduction. It can create jobs. It allows people to, reduce drudgery. It keeps people from expending so many calories on manual beating and that kind of thing. So we're trying to provide evidence for other organizations to be able to support thresher fabrication programs. And then we're also working on figuring out exactly how men and women differ in thresher operation and maintenance, and what kind of training and skills are needed for both. So we have built and are building a training program for end users for maintenance and repair. So we found that the biggest problem with threshers is that they go to the field with inadequate training of the end users. So sometimes, they're told how to operate, but they're not told how to fix, not told how to, open up the top of the machine, or, fix a belt or fix a pulley, or what to do if the engine stops working. And one of the biggest things I found is that nobody was being told how to grease bearings. And that included the fabricators were not greasing bearings, which it's important for the life of a bearing that it receive constant grease. So we also want to make sure the end users also have the necessary tools that go along with the threshers. So we're encouraging our fabricators to include a maintenance package that would be paid for by the end user, but would make sure that they have the correct things that they need to be an operator and maintainer. So the minimum tools that we've found that are needed, if you have a big thresher like this with wheels, then you're going to need a jack. You need the proper wrenches or spanners, as I think they call them in many parts of Africa, to be able to, to be able to loosen or tighten the engine, the belts, the pulleys, take the top off, whatever. You have to have proper wrenches or spanners. Motor oil, so we include that in the package to remind people that the engine oil does need to be changed. We go over that in our training, how to change that. We provide a grease gun and grease. So for many people in rural communities in sub-Saharan Africa, mechanization is something that's new, and most of the basic skills need to be taught. So here you can see we're teaching an operator how to load his grease gun, and then we'll teach him how to grease the machine. And we teach them how to change the oil, how to check the oil, how to make the motor run when it won't start. What are the possibilities? What could be wrong? So we troubleshoot the entire machine when it goes to the field. So we find that the more people who understand the equipment, the longer it's going to last. So if you're afraid of your equipment, if you think it's something that you can't do, then you're not going to be a successful operator and maintainer. So really understanding the equipment is vital to its success. So the cost of the multi-thresher in Ghana, the materials, the metal, the wheels, the axles, the pulleys, that kind of thing, is about $1,200. The diesel engine for 8 horsepower was $525. Machining, which they have to have certain shafts machined, pulley keyways machined, that was $150. The guys that we have doing it in Ghana are only charging about $150 in labor, which is extremely cheap for how long it takes to build one of these. But they find that that's still a profitable level of labor charge. Then to get it transported to the village, about another $150. So they're selling these for just a little under $2,200 in Ghana. And so that is too much money for most smallholder farmers, but we're finding it's not necessarily too much money for a service provider or a larger farmer who have access to financing options or who have savings. And I should also mention that the service providers that we know say that the thresher pays for itself in 1 to 2 years. So what can the SIL mechanization program do for you? First, we can provide thresher designs, and we can provide our end user training module. We can help you host training programs for in-country fabricators, or we can also provide a package program for fabricator and end user training. So that would be where, so we can either consult with you and tell you how to successfully do a training yourself, or we can come to your location with funding provided by you and provide the training and the end user, the fabricator and the end user training ourselves. And then the cost of that would depend on your location and the number of fabricators you want to train. So Rose, that's all I have. Do you want to do the second poll?
Yes, thank you very much, Carrie. And after we do these polls, we'll be segueing over into questions and answers. So now's the time, if you have any more questions to ask, to please feel free to put them in the questions pane or the chat pane in your control panel. But in terms of our last couple of polls, are you interested in informational materials about the thresher, such as the handout? We'll be wrapping this up shortly. And great. Great, so we'll make sure we get plenty of information out to you, because everyone said yes. And additionally, what kinds of information would you like to have about the thresher? Anything about price, training, capacity, or design and production? And if you have any other input, feel free to also reach out to any member of the SIL team and let them know that as well. But for the purposes of these polls, price, training, capacity, or design and production. I'm closing it down. Great. So most people said design and production and training.
So Rose, I want to make one comment on that. So the reason that we started, we went out and tried to do our own design is because, there has been many small threshers designed over the years, but what was difficult was to find actual printed, paper copies of the designs, or some way we could access the design with actual measurements, and that was hard to find. And so that's why we went ahead and just basically started from scratch. So our thresher is not necessarily, there may not be anything terribly original in it. It's probably a compilation of a lot of different aspects of threshers that have worked over the years. But the thing is that what we think is important is that now you can have access to these designs and training, and so that people can actually start to make it and utilize it.
Great, thank you. And at this time, I would like to once again just remind you in the handouts bin of your control panel There's a thresher packet which has a lot of the information that was presented today and provides you with Dr. Clark's contact information and our website. At this point, I'd like to introduce SIL Director Dr. Peter Goldsmith, and we'll segue into the question and answer portion of the webinar. Pete?
Yeah, thank you, Rose. Super talk, Carrie. Great as usual. Another thing I'll say before I get into the questions, just to follow up Carrie's point about there being nothing fantastically new. Technically, there's not a miracle here or anything like that. That a lot of this, but one of the things SIL was tasked with from the beginning back in 2013 was evidence. And the research for development model really depends on good evidence and getting data, testing in controlled environments, collecting data and providing a solid scale-up plan. And that's been kind of Dr. Clark's modus operandi for the thresher. And so there's a lot of interest, I think a lot of activity, and she brought all that together, brought designs, learned from those, and then from that emerged through trial and error experimentation and then prototypes and beta testing, the model that she demonstrated. So this research for development and evidence, providing evidence to the policymakers and practitioners and fabricators and input suppliers really was at the heart of the mechanization efforts that Dr. Clark is leading. So we have some really good questions here. And let me, there are some that were kind of off. I'm going to focus first on the thresher related questions, and then we have some tangential questions. Claude Covise from Pop Diesel asked a question, maybe just to revisit. I know you touched on it briefly, Carrie, about the impetus for the challenge. What is the real challenge that soybean farmers face that made you realize that threshing was a key bottleneck, and what type of bottleneck effect did it have?
There was a couple things. One was that we've been told by multiple people that, so we were working mostly in Ghana, and we were told that locally produced soybean in Ghana is not the poultry or the aggregator or the end buyer's first choice. They prefer imports because the local produced soybean was so full of rocks and sand from being threshed on the ground with stick beating. So the quality was so low, it was not a desirable product. So the only way to get that to improve is to improve your threshing methods. Also, it's very laborious. It's, if people know they have that harvest waiting for them at the end, they're going to be less likely to increase production. So anything that helps people be more efficient and more productive will help them raise incomes and improve food security. So we feel like, I myself, having been a soybean breeder for many years here, I know that you can always plant a lot more than you can harvest. So anything to do to help harvest seemed to me like a way to help improve production for smallholder farmers. And so we were also seeing, we did see some cost share programs in Ghana where they were importing threshers, and the imported threshers were running around $8,000. So even though it was a 70-30 cost share, most farmers couldn't even afford the 30% on the cost share because the thresher itself was so expensive. And then I experienced meeting some blacksmiths and seeing their capabilities and realizing that their major limiting factor is, there's two things. One is quality materials, which sometimes you have to travel kind of far, but they were able to find. And then the second thing is financial capability. So one of the issues that we do see is that let's say we have a service provider or a nucleus farmer that wants to buy a thresher and they don't have the money and they're going to get bank financing, The bank isn't going to let them pay 100% upfront for the thresher. They pay for it when they get it. But the fabricator needs some upfront money to buy the materials so he can build the thresher. So financing is still an issue, but I think it's one that we're trying to figure out ways to solve. But other than those, those two impediments that they had, most of the barriers I think are surmountable, and that we can get local production and increase job creation around agricultural mechanization in these countries.
Thanks, Carrie. Really good. So we have a next question comes from Abdoulaye Nadal from USAID Senegal, and kind of is a nice segue to the previous question and your answer about cost and credit, which is really, really critical both for the fabricators and for the purchasers of the thresher. His question is, are producers able to put money and to purchase the thresher? And where do you see it being? Mostly individuals? And I think you mentioned that it was scaled to be more of a community level or anchor farm level rather than an individual, or farmer groups.
Yeah, so we've seen it go a couple ways in Ghana, but yeah, I do not think this is affordable to your typical smallholder farmer by himself, unless so we do have a funding group in Ghana, or NGO development organization, that does cost share. And so they do have a 70-30 cost share. And so they're actually working with women. So the women are able to buy the threshers with the cost share. Then from the money they make off that thresher, off becoming a service provider, they can then put that towards buying more threshers, or they can loan it to someone else to become a thresher. So sometimes cost share programs can be really vital for just getting this technology out there to start with, and getting it into people's hands, and then they can start making money with it. Because this is actually thresher service provision can actually be extremely lucrative for people who own the threshers. But like Pete said, we did scale this towards a service provider business. So this would be somebody who would be capable of getting some financing, or who maybe is working with, he may even be village financed. Maybe there's a village group that puts their money together so that they have a thresher available. And then as the service provider makes money from providing the services, then he pays back his original investors, or he pays back the bank. So we also have another group in Ghana, fairly large group of what is called nucleus farmers. So these guys that have, they work with smaller farmers, and they aggregate, and they also provide them services. So the nucleus farmers usually are able to get bank financing to buy the thresher. So basically, I guess the answer to his question that I feel is that there either needs to, funders can provide cost share that helps get the technology out there, and gets it known, gets it in demand, and then as demand goes up, supply can go up, maybe costs can come down. But if we can't get it out there in the very beginning, it's gonna be hard to become successful. But so then for the smaller guy, they need cost share. For the larger guy, some sort of financing opportunities. But we are seeing that work successfully in Ghana. I mean, people are finding ways to get the threshers.
Thanks, Carrie. Yeah, so this is a critical aspect, the idea of credit, whether it's trade credit from metal suppliers, bank credit. That's something that it's part of the business training, but also part of, when you think about this, project design and sustainability of a locally manufactured thresher. Carrie, we've got just some great questions. The next question, which you touched on briefly, comes from Gilbert Kamiyala from USAID, I think USAID Malawi, but from Malawi. And Gilbert wanted to ask about the availability of the design, and how you get access to it and how it's bundled with the training, because as you mentioned, you don't just want to, doesn't do much good to just send out the design. The training is really, really critical. So explain how that works, Carrie.
So people can just contact me. So we're actually doing a training in Malawi in December, which I would invite Gilbert to come by and see. So that is in conjunction with Compatible Technology International and CNC Fabrication in, I think, Lilongwe. So the way the training works is that if you buy the package training, SIL will bring the trainers, and we set up in like maybe a community, or like a technical college or some sort of a workshop where they have welding plants. We locate fabricators with high capability or who are already in agricultural equipment. We bring them in, we teach them how to read the designs. We build a thresher. We work with them on every aspect, from reading the designs to selling to customers, quality control, everything that's necessary for a well-functioning thresher. And like I said, the price of that depends on like the one I'm doing in Malawi. I'm gonna probably do one in Uganda at the same time. So since I'm already in Malawi, that's cheaper for them because they don't have to pay for our trainers to go to Uganda since we're already in the area. Then it depends on how many people you want to train, because we do provide for the trainees. We do think it's more feasible if you provide them with some travel, their lodging, and their meals. And then usually there's a facility charge, and then the equipment, and then we buy the materials to build a thresher. So we're looking at anywhere, it could be anywhere from $10,000 to $25,000 to put on a training. And then, so if you didn't want to do if you felt like you had the capability to do your own training, or you have fabricators in your country who could read plans, then I can provide those plans with you, and kind of, work with you as you go along, getting people's capabilities raised to build the threshers. So it would so basically, we just communicate with me, and we'll figure out what direction you want to go with the training and the working with the fabricators. And so Thanks. I did mention that the final design will be available near the end of August, because we do have one more session in Ghana where we're going to go through this thing one more time, and make sure and just make sure that we've got everything exactly the way we want it to be.
Great, Carrie. Thanks. Hey, we have another good question from Jinta Gadabu. Gadabu from Tajintu Investments in Malawi. Jinta asked a straightforward question about the output in terms of kgs per thresh per hour for soybean, and in terms of, and you mentioned something about in terms of ability to feed it and how much it could handle. What are some of the constraints on its capacity, and what is its capacity?
Okay, so I didn't actually put those numbers in because I found during field testing that it made a huge difference, the size of the soybeans. Like it could, if you had large soybeans, you had double the capacity by kilogram. But basically what we found was that, like I said, like Pete and I said, the constraint is how fast you can feed it. And that's just a matter of, somebody has to pick up a bundle, carry it to the guy, to the machine. The guy has to stick it into the feeder and shoot. And so that's what slows you, that's what limits the speed, not the machine itself, but the human feeding. So I believe we were doing in maize feeds much quicker than soybeans because it's you're just throwing in cobs. And we were doing about several hundred kg an hour. I think it does about, it probably does, I'm just going to guess about 400 kgs an hour, but in maize, and in soybeans, maybe 100 kgs an hour. But again, it's not the machine, it's the feeders that control that speed.
Thanks, Carrie. And a question from Compatible Technologies, Don Jacobson says, first a comment, he says, this is great work, Carrie. The training component is key, as is the quality assurance. Are you concerned about the uniformity of production once the fabricators are trained? How do you envision ongoing quality assurance?
So yeah, so quality, that was one of the things that we found out after we did the first training, was that not everybody has the same quality. And so we are doing a training in August on just quality, and that focuses on quality assurance, and then production efficiency, where we're going to work with fabricators to make patterns and forms, and then everybody would have basically the same pattern and form. So then you get consistency from model to model and from fabricator to fabricator. And the reason we didn't include that in our first training is because we didn't, in our first training, we hadn't settled on exactly what thresher we were going to go forward with. So now that we've field tested them and we know what thresher we want to go forward with, that will become part of any future trainings that we work on quality control and uniformity and production efficiencies. So I know you said Don's with Compatible Technology International, and one of the things that they like to see is that it become basically a certified product in the country. And so when we do the Malawi work with CTI, that will be something that will happen, and then that will be added to the future of this program, that so that we get fabricators so they're actually doing something that the government agencies have looked at and said, yes, this is safe and works.
Yeah, really good. One of the questions, I know you mentioned it, but maybe Dave Wilson-Purdue missed part of it, or we could provide a little more detail about, he asked, will the design documents, drawings be published online and be publicly available? Is it considered open source? And so for the first part, it is considered open source, but maybe talk about open source, quality control training, and how those all come together, Carrie.
Yeah, so it is open source, and I think once the program starts to take off more, and we see how people utilize it, then we'll make them just available at the click of a mouse. But for now, I just want people to contact me so that I can work with you. I will give you the plans, but I want to work with you and follow up with you and see what kind of backup you were able to give your fabricators, and where the program went. And I want to be able to follow the success a little bit. So yes, if they contact me, I'll give them the plans, but I just want to stay in communication with them on what they do with it and how it works out, and how we do make sure that we maintain quality.
Great, thanks. We got a great question from Senegal, from Aliou Nadaye, from CTI, from Compatible Technology. So he asks, how do you deal with the logistics to deliver the technologies to farmers in remote areas? Do you do it yourself, contact with service providers? How does it work?
So right now we have a pilot program in Ghana, and so we do put a little more energy into that one than, a little more energy and a little more money into that one than, like, if you take this and you do it with your own program, you may have different ideas on how to follow up. But so what we will be doing is training. We'll be training the trainers. So the first person in that line is the fabricator themselves, because they shouldn't let any machine go out their door without properly training the end user. And that's going to take, some effort and time on their part, but it's going to mean that they're going to have a better business in the long run. and a more successful business, and one that people are more likely for their machines to continue to function, and so they'll get more word of mouth customers. So first we train the fabricator on maintenance operation, that he then trains his end users, the people that buy it. We'll train NGOs and extension people, so that as extension people, if they come to a village and they see a thresher broken down, then maybe they can give the people some ideas on what they need to do. But basically, the fabricator becomes the central pivot point of the thresher, and that's the person that and actually we are going to have a warranty program. So the fabricators will provide warranties for craftsmanship, but then we'll work with them on how then do you do customer follow-up without them taking all your time and all your resources, but how do you make sure that what you've sold keeps working? So it will, for it to be sustainable and for us to build capacity, it needs to be in the hands of the commercial providers, whether that be the fabricator or the end user. Of course, at this level, us thinking that this is going to be for service providers, those should be professional people. And we hope, like in Ghana, that we will, as people buy these, we will do a training of the organizations that have brought those people into our sphere of influence. So, for instance, the program Advance has brought a lot of farmers into buying these threshers. So we'll train Advance personnel who are, stay in Ghana and who are Ghanaians in many cases, how to train people to operate, and maintain the threshers. There's also a manual that will go with the threshers in operation and maintenance for the end users.
Thanks, Carrie. A couple of questions, maybe kind of next step-ish kind of questions. Our last question, I know we're bumping up against the hour and we know people are busy. It has to do with, I know Dick Tinsley from the US and Claude Covisse from Pop Diesel US raised a question about the integration with tractor power. We've been working with the Ogun tractor and another open source technology. Where do you see that connection with tractor power moving forward, and kind of next stage of research with the interplay between threshing and tractor power?
Okay, well, one of the interesting things is that IFPRI, which is it's a USAID funded economic unit for international development, did a very big study on tractor powers in Ghana and found that tractor service providers only become profitable when they include threshing services. So, and many of them do now, but only for maize. And so this allows this thresher, you can just put instead of the diesel motor, you can build it even cheaper if you put a tractor PTO drive on it. So then it would go hand in hand. And we figured that would probably also be, some of the early innovators and early service provider customers will be the tractor service providers. So this allows them to expand their business and become more profitable. And then also not only work with maize, but also other crops. And then you did mention the Ogun tractor. So that's another program that we're trying to get started in Africa, where we have an open source tractor that you can actually build in Africa for a small licensing fee. And it's a hydraulic drive tractor that also has a PTO that can run a thresher. So definitely I see a link between the threshers and the tractors, but we also felt it was important that we have the model with the diesel engine on it, so that you don't have to have a tractor to be able to use this thresher, because in many cases the tractors are not available year round. They may come from different parts of the country, just do field land preparation and then leave again. And so we don't want to be dependent on a tractor. And I also want to mention that in Ghana, we're working with a company called Motor King, which are these motorcycles that have a cargo bed on the back. And there's a certain Motor King where it has sprockets and a flywheel underneath it, and you can actually run a thresher off the Motor King. And so we have 2 designers now in Ghana that are working with Motor King to design a thresher that can be run off some other power source other than a tractor or an engine. And so we hope to see these threshers get assimilated into and linked with all sorts of other different technologies.
Great. Well, thanks you
Carrie.
again, Dr. Clark. Thank you, Pete, Dr. Goldsmith, the SIL director, for running the Q&A. And thank you all very much for joining our webinar. If you didn't get your questions answered today, they will be put into a separate question and answer document with all of the answers, and that will be made available on our website with the presentation slides from today, the Thresher packet handout from today, and a recording of the webinar. So if you missed out on anything and you want to come back and review it, this will all be available on our website. And for those of you who haven't visited it yet, that is soybeaninnovationlab.illinois.edu. All of our materials are on there and all of our contact information is on there. So once again, thank you so much to Dr. Clark for sharing her time and expertise today. Thank you, Dr. Goldsmith, for joining us. Thank you for everybody for joining us, and we hope to see you next time at a future webinar.